if my right hand side is not 0, let's say if this is g, what I get is this is going to be g, partial u partial c is going to be g, and then along the, you still have exactly the same characteristic line, but along the characteristic line, your partial u partial c is going to be g. That means you shouldn't expect the solution to be constant along the characteristic lines, but instead you can still solve the solution on these characteristic lines using an ODE solver, right? You can just integrate along the c direction because this doesn't depend on the other direction. It doesn't. So the solution along one particular characteristic line does not depend on the solution anywhere else, right? So for example, here in this plot, in the Burgers equation, if I want to know what is the solution here, okay, the only thing I have to do is to trace back along the characteristic line and find out what is my initial condition here. That's true if my right hand side is 0. That's still true if my right hand side is not 0. If my right hand side is 0, what I need to do is trace back and say the solution here is actually equal to the solution here. If my right hand side is not equal to 0, all I have to do is still trace back and then solve an ODE using this initial condition as an initial condition and evolve, okay, using this ODE solver. I mean, it's not even a real ODE, it's just the integration, right? I just integrate along the characteristic line to get my U. It's only an ODE if my G depends on the solution U. Does it make sense? So this gives me very clearly that this equation is a hyperbolic equation, right? Right, remember, what is a hyperbolic equation? A hyperbolic equation has the domain of dependence and domain of influence propagated at predetermined speed. And this equation, we have already said that the solution here depends only on the initial condition backward along the characteristic line. And it only depends on the right-hand side, the values of the right-hand sides along the same characteristic line. That means the domain of dependence of any point here is just one single line at a single slope. It for sure has a propagation at a fixed predetermined speed, right? So this tells me that all conservation laws or conservation laws are hyperbolic. All conservation laws written in this form is hyperbolic. You can add additional terms. For example, you can add a second derivative term on the right hand side to make it kind of a mixed hyperbolic and parabolic. But like if the right hand side does not depend on the derivative of u, then this is going to be a purely hyperbolic equation. Okay? Right. So now we have done analysis to the smooth region. So why this analysis only applies to smooth regions?